Okay, next unit is talking about the electrochemistry or reduction reaction, oxidation reduction reaction, or redox um, reaction. I am going to record this and post it before the class time tomorrow. So I will use the class time to answer your questions. So hopefully, if you get a chance to view it before the class time, and then ask your questions, or if you have any questions from the exam or quizzes, you could ask during the class time. Electrochemical reactions, those are the reactions that involve oxidation reduction reaction. In a spontaneous reaction, the energy released by the spontaneous reaction, which is converted to the electricity. Or if it's non-spontaneous reaction, then the electrical energy is consumed for the non-spontaneous reaction. In oxidation, what's happening in oxidation, one element is going to lose electron, or the oxidation number is going to increase. So loss of electron is going to be oxidation. Magnesium is losing 2 electrons. Each magnesium is losing 2 electrons, changing to magnesium with 2+ charge and releasing 2 electrons. This is per magnesium. So magnesium has been oxidized. What's also happening, oxidation number for magnesium is increasing from 0 to 2+. In order to be able to assign the oxidation number, we're going to look at some of the rules. But oxidation number for magnesium here is 0 because it's the element in elemental state. All elements, they have 0 oxidation number. Oxygen in nature appears as O2 gas, so oxidation number is 0 at the way it appears in the nature, in the elemental form. And then we have our magnesium oxide in a compound oxide. It's -2, and the total number of oxidation number is 0 for magnesium and oxygen. Magnesium is +2 because it's in group 2A. So magnesium is going to gain the 2+ charge, and oxygen is 2-. Both of them is basically rule. Elements in group 2A, they gain the 2+ charge when they are engaged in a compound, and oxygen in the oxide form is going to gain 2- charge. So again, per oxygen, every oxygen is going to gain 2 electrons. So we have 2 oxygen, it's gaining 4 electrons, and it's changing to oxygen with 2- charge. How do we know that first one, the magnesium, is the oxidation half? Because the electron appears on the product side, so we know that that is oxidation half. In the second half reaction, electrons are being consumed. So this case, you have the reduction half because oxygen is gaining electron, or electron appears in the reactant side, and the electrons are on the left side of the arrow. It separates the reactants from product. You have the reduction half. So we have the oxidation half, reduction half. We can divide the oxidation reduction reaction to 2 half-A reaction. So for the oxidation number, there are some rules. First rule is the free elements. Elements in free state, they have oxidation number of 0. So you have the same, even though it's a diatomic, or this one is a tetraatomic, still is going to be 0 because it's just one type of the element or the atoms. In a monoatomic ions, oxidation number equals to the charge of the ion. So lithium 1+ is going to be +1, and Fe3+, oxidation number for that is going to be equal to the charge, which is a 3 plus, and for oxide is going to be 2 minus. Oxidation number of oxygen is minus 2, except in peroxide. So if you have like a sodium peroxide, oxidation number for oxygen is going to be minus 1. Hydrogen peroxide, oxidation number is minus 1. But in any other oxide compounds, the oxidation number is going to be minus 2 for oxygen. For hydrogen is going to be plus 1, except for hydride. That means you have hydrogen combined with a metal. So in this case, metal is going to be positive and hydrogen is going to be negative. So if in the hydride is going to be negative 1, except in this case that is combined with only metals. Then so you have a metal hydride, it would be negative 1. For any other compound, hydrogen is going to be plus 1. Group 1A would always be plus 1 in a compound, unless it's in the free element. In free element is going to be 0, no charge, it's not a compound. And the metals in group 2A is going to be plus 2. Fluorine would always be negative 1 because of the high electronegativity of the fluorine, and it has already 7 electrons. In order to be satisfied for like a noble gas, it only requires 1 more electron. Sum of the oxidation number for all elements in a compound is going to be 0. So if you have a compound that is, let's say, sodium sulfate, so if you add oxidation number of the 2 sodium, 1 sulfur, and 4 oxygen, the total oxidation number is going to be 0. If you have a polyatomic ion, sum of the oxidation number is going to equal to the charge of the polyatomic ion. So the total charges here, oxidation number for hydrogen, carbon, and 3 oxygen is going to be equal to negative 1, which is going to help us to determine the oxidation number for the element of an interest. For example, let's say if we have HNO2, what's the oxidation number for nitrogen? The rules that we have for hydrogen, we have plus 1. Total number of oxidation number for all of that is going to be equal to 0. Oxidation number for nitrogen is an unknown, so we don't know what's the oxidation number for nitrogen. Plus 2 times oxidation number for oxygen is going to be minus 2. Total equals 0. So you set up an equation in order to find the oxidation number for nitrogen in this case. Because if it's not part of the rule, it could have different oxidation number. It can go from the number of the group to minus of the group number. Let's say nitrogen is in group 5A. It can go anywhere from plus 5 to minus 5. So it could be in this range, oxidation number for nitrogen, because it's not part of the rule. So you set up an equation and solve for x. So in this case, plus 1 minus 4 plus x equals 0. Minus 3 or x minus 3 equals 0. And x equals plus 3. So oxidation number for hydrogen is going to be 1. For each oxygen is minus 2. That's the oxidation number for oxygen, and oxidation number for nitrogen was calculated to be plus 3. When you add them all up, it adds up to 0. Now, for HNO3, if you try different nitrogen in different compound for HNO3, hydrogen again is part of the rule, is going to be plus 1. each oxygen is a -2, and we are trying to find the oxidation number for nitrogen. So it's going to be +1 plus X plus 3 times -2 equals 0, because the total number of oxidation for HNO3 equals to 0. There is no charge for it. And then you're going to simplify it. It was +1. So it's the 1 minus 6, and then you have the plus X equals 0. Minus 5 plus X equals 0. So what should be the value for X? X equals plus 5. And that's how you find the oxidation number for nitrogen in this compound. You see, it's a compound specific. So for this compound, the oxidation number is +3. For the compound HNO3, oxidation number for nitrogen is +5. Is within the range of -5 to +5, so both of them are acceptable. And for each one, you're separating the equation separately based on the elements, other elements that are in the compound. And if it's a compound, the total charges is going to be equal to 0. Oxidation number for all of them equals to 0. If it's a polyatomic ion, it's a different story. Then it equals to the sum of the oxidation number for elements in polyatomic ion equals to the charge. So SO4 2 minus SO4 is for S is going to be X, because it's not part of the rules that we learned, plus 4 times minus a 2 equals 2 minus. This 2 is the charge for SO4, is not the oxidation number for the oxygen. Oxidation number for oxygen is -2, but that's part of the rules. So X minus 8 equals -2. If you bring this to the other side, it would be X or 8 to the other side, 1 or the other. So 8 minus 6, X minus 8 plus 2 equals to 0. X minus 6 equals 0, and X equals plus 6. And if you would have taken the -8 to the other side, probably you didn't have to write this way. So either way is correct. So basically X equals +8 minus 2, and X equals plus 6. Same thing. Okay. How to balance equations for oxidation reduction reactions? How would you balance it? It's not as easy as the methods or double displacement or single displacement reactions. In this case, you have to be worried about the charges. So you have to balance the element, and you have to balance the charges as well. There are a couple methods. We are going to talk about the half reaction method, balancing redox reaction using half reaction. So what you do, you are going to separate the molecule to two half reaction. You separate the reaction or divide the reaction to two half reaction. Fe2 plus changing to Fe3 plus, that would be one half of the equation, and the other half of the equation, dichromate is changing to chromium 3 plus. So that is another half a reaction. So you have two half a reaction. Now we are going to try to balance the two half reaction. And after we balance the two half reaction, then we add them together. So first you separate it, then you balance each one separately. After you balance each one separately, then you add them together. How do you balance? First, you balance the elements. For the first reaction, Fe2 plus going to Fe3 plus, The number of Fe is the same on both sides, so you don't have to change the coefficient. The elements are balanced. The charge is not balanced because the charge for Fe3 plus, we have 3 plus, and this side we have 2 plus. You can only add electron, you cannot subtract electron. So you add electron to the side that is more positive. And how many electron you are going to add? You're going to add enough electron to make sure both sides they have equal charges. Doesn't have to be 0, but it has to be equal on both sides. So if I add 1 electron to this one, 1 negative charge with 3 positive is going to be equal to 2 positive charges. So that's the only thing that is missing, 1 electron adding to the product side. Basically, Fe has been oxidized because electron appears on the product side. For the second one, first we have to balance the elements. To balance the chromium, we have 2 chromium and 1 chromium here. We are adding coefficient of 2. So the coefficient of 2 is added to balance the chromium. To balance the oxygen, we add water. We add 1 water for every missing oxygen. How many oxygens are we missing on the product side? It's 7. So we have to add 7 H2O to the product side. Now, we balance the chromium, we balance the oxygens. What about hydrogens? Now, hydrogens are not balanced. We have 7 times 2, 14 hydrogen on product side. I can add 14 hydrogens to the reactant side. So, to balance oxygen, we add water. To balance hydrogens, we add H plus in acidic solution. We add H plus. Now, the elements are all balanced, but the charges are not balanced. What are the total charges I have on the product side? I have 3 plus, but I have 2 of them, these ions. So 2 times 3 plus is going to be 6 plus charges on the product side because I have 0 charge coming from water. In this case, I have a 2 minus and 14 times 1 and 14 plus. So overall is going to be 12 plus charges. We are only allowed to add electron. And which side are we adding electron? We are adding electron to the side that has more positive charge. So I'm going to have to add electron to the reactant side. So I'm adding 12 electrons. So I add 12 electrons plus the 12 positive charge is going to be, I'm going to take it back. We only add enough electron to make it the same on same number of electrons or same charges on both sides. I have 12 positive charge here, 6 positive charge. So I have 6 extra charges on the reactant side. So to cancel the 6 positive extra positive charge, all I need is the 6 electron. I don't need 12 electrons. So I'm adding only 6 electrons here. So I have 6 plus charge here, 12 plus and 6 minus added up is going to be 6 plus charge. On both sides, I have 6 plus charges. Now, we balance the oxidation half, we balance the reduction half. We are going to add the reactions together. Before we add the reactions together, we have to make sure that the number of electrons are the same on the opposite side, but they must be the same in order to add them. So I have to multiply the oxidation half by 6 in order to get the number of electrons the same for oxidation half and reduction half, because for reduction half I have 6 electrons, oxidation half I have 1 electron. I'm multiplying the oxidation half by 6. So this is going to be 6 electrons, 6 Fe3 plus, and 6 Fe 2 plus. Then you add the two together. To add the two together, you're going to draw the arrow sign. When you draw the arrow sign in the middle, anything that is on the right side of the arrow will be added to the right side of the final product. Anything to the left side of the arrow is going to be added to the left side of the arrow. If you can simplify, you can simplify before adding, so you don't have to simplify it again. So I can simplify the electrons. I have 6 electrons on the product side, 6 electrons on the reactant side, so I could just cross them out. And what is left here, I have 1 Cr2O7 plus, I have 6 Fe2 plus, 6 Fe2 plus. Then I have 14 hydrogens, 14 hydrogens. That's it. On the product side, I have 2 Cr3 plus 6 Fe3 plus 7 H2O. Now my equation is balanced. The number of oxygens, number of hydrogens, number of chromium, number of iron. The electrons were balanced, but we can cancel from both sides to simplify the reaction. Okay, one more time, the steps. First, you cut the reaction to 2 half reaction, oxidation and reduction, half reaction. You balance the elements by using numbers for coefficient. If it's both of them are 1, then you don't need to change the coefficient. It's balanced. You balance the charge by adding electron to the side that is more positive until you have same charges on both sides. The side that is missing oxygen, you add 1 H2O per every missing oxygen. The side that is missing hydrogen, you would add H plus for every missing hydrogen. So acidic solution, acidic aqueous solution, you have plenty of water, you can have plenty of H pluses you can use for anytime you need to balance it. So the half reactions balance, electrons must be the same. So you multiply the oxidation half by 6 in order to get same number of electrons. Now we can cancel the electrons and add the two half a reaction. And your equation is going to be balanced. If the reaction is balanced in a basic solution, after you follow all these steps, you're going to add hydroxide. How many hydroxide are going to add? You're going to add enough hydroxide to cancel all H pluses, because H plus should not be visible in a basic solution. So basically in this reaction, you're going to add plus 14 hydroxide. When you add the 14 hydroxide with 14 H plus is going to give you 14 H2O. If you add 14 hydroxide, you have to add also 14 hydroxide to the product side, 14 hydroxide. Out of the 14 water that you're getting here, 7 of them would be canceled with the one on the product side. So you would get 7 H2O. So after you are done with balancing equation acidic solution, if the question is asking to balance it in a basic solution, you add hydroxide. How many hydroxide? As many as H plus that you have, and you're going to add same number of OHs to both sides of the equation. Okay, I'm going to stop the recording here because I want to make sure that the length of the videos are not too long. After I experienced one with the Unit 5, it was very long.